All right, welcome everyone. I'm Rajneesh Gupta, and this is our mock interview series. This is the mock interview for network security engineer role. Okay, the role where you are expected to do a work on network security, firewall, perimeter security, and everything around it. Okay. For this mock interview series, I have Jamin with me, and he will be the interviewer for this series. I mean, for this video, and I'll be the candidate. So before we go ahead and start with our video, make sure you subscribe the channel. And if you are an existing subscriber, press the bell icon so that you get notified immediately. If you want to know the cybersecurity career roadmap, on Saturday I conduct a cybersecurity career roadmap webinar. It's a completely free webinar, so you can join the webinar and learn more about it. The link is in the description. Let's get started. Hi, Javin. How are you?
I'm good, Rajneesh. How are you?
I'm good. I'm good. Thank you so much, Javin, for having me here.
Okay. So, Rajneesh, let's get started. My first question is, what is the difference between stateless and stateful firewall?
Okay, so stateless firewall is more about it doesn't perform inspection of every packet. For example, probably let me first tell you the stateful firewall first. Stateful firewall maintain a connection table. In this, whenever a packet passes through the firewall, it makes an entry into that connection table. Okay, so let's say if it is a part of three-way handshake, the first packet goes from the internal user to the internet. If the return traffic comes in, the firewall will first verify if it is the response to the existing packet or existing session or is completely a new one as a part of three-way handshake in the connection table itself. If it is a part of the existing session, it will be allowed immediately. If it is not a part of the session, it will be dropped unless we have an explicit rule for it. Okay, so the benefit is we have a session table maintained in the connection table. Second benefit of stateful firewall is it can also perform the packet inspection as well. So as in not just like the advanced next generation firewall, but it can actually look at the packet session, TCP header, and everything on that level. Whereas if we talk about the stateless firewall, it does not maintain any connection table. So it treat every packet individually. So it does not maintain any context behind every packet that if it is the response to any of the existing session or anything new. For when I'm talking about the session, it's always about the TCP three-way handshake where we have SYN coming in from the client, then SYNAC coming in from the server, then finally the ACK. Okay, so on that context, this is being used. Stateful firewall nowadays, all the firewalls are stateful. All the firewalls that we deploy in the network, around 90% of the firewall. If we talk about stateless firewall, this could be I could give you an example of maybe router access list. Okay, as simple as router access list, or we even use it on the AWS some access list as well, wherein if we have a huge number of traffic, we want fast forwarding. So in that case, we use firewall rules, and it takes less space as well because, as I said earlier, stateful firewall maintain the state connection table, so it consume more space as well. So yeah, that's the main difference. Yeah.
Okay. So, Rajneesh, can you tell me then what is TCP three-way handshake?
Yeah, sure, of course. As I just said, TCP three-way handshake, we have SYN coming in from the client. So what happened is it's basically a session. Okay, in the client server method, whenever someone need to talk, they first have to establish a TCP three-way handshake. If they agree to talk on the TCP, okay. If they want to talk on UDP, it doesn't require. So if they want to talk on TCP, which is reliable communication, and it's reliable because there is an acknowledgement for every packet. So it all start with client sending this SYN message, which is synchronized message, wherein the client first send the SYN message saying that I want to talk to you. It's as simple as that. It indicates that the client is interested in talking to you. Maybe I want to open google.com, so that represent that I want to talk to google.com, right? Now, once the packet reaches to the google.com, it's a basically a layer 3 packet, and of course layer 4 header as well, TCP header, where these TCP flags are set. So there are around 6 flags. So if the SYN flag is set, that means it represents that it's SYN flag, SYN packet. On returns, the server acknowledge it by setting the acknowledgement flag, and it also added its own SYN flag as well, saying that yes, I acknowledge this, but I also want to talk to you, or I'm ready to talk to you. Okay. Then finally, the client acknowledge the SYN flag sent by the server, and this completes the three-way handshake. So this SYN, SYNAC, and ACK completes the three-way handshake. Of course, there are multiple other parameters involved as well, where the sequence number is sent by the client, then the another sequence number will be sent by the server, and this keeps going on. But these are the major components of TCP three-way handshake. So yeah.
Okay. So Rajneesh, are you aware about OSI model then?
Yes, absolutely. So OSI
What is it?
model has got So OSI model has got 7 layers. Start with the physical layer at the bottom. So this consists of electrical, all the devices, physical connection, and everything around it. Then we have data link layer, which is responsible for transmission of a data frame transmission without any error into the network. So this could be, for example, we have switch working on the layer 2, where it forward the data based on the MAC address. Okay, so the MAC address is used in the Ethernet network to store information about every devices. Then we have layer three, which is network layer, where routers basically resides, which forward the traffic based on the IP address. Okay, that's where the routing and forwarding of the packets really happen. Routing protocol and IP routing also exist here. So let's say I want to ping any specific destination, so I use ICMP. So that's work on the layer 3. Routing protocol like OSP or BGP works on the network layer itself. Then we have transport layer, which is on the layer 4, which is where we have TCP and UDP. TCP is reliable, UDP is unreliable. So if we want to send a broadcast frame, we'll use we'll use the UDP. If we want to have one-to-one but reliable communication, guaranteed delivery, we'll use the TCP in that case. Okay. Then we have session layer, which is about managing the session, terminating the session, establishing the session, everything. We have presentation layer, which is the 6th layer, which takes care of data conversion, encryption, encoding, compression. So it's all taken care by the presentation layer. Finally, we have the interface, the user, that the layer on which the user interact directly. So this is where we have HTTP, DNS, FTP. All this protocol really works on it, or maybe SMTP. So the moment we write an email and send it across, this goes by the SMTP, and this is where finally the SMTP works. So yeah.
Okay.
Mm-hmm.
So then, Rajneesh, how the Traceroute work?
Well, Traceroute is basically a diagnosis tool used in the layer 3, and basically, Traceroute works by sending packets with the incremental TTL value. So TTL value is time to leave packet. Once that it's set to 0, that means packet get expired in the network. So maximum value is, I guess, 255. So any packet cannot have TTL value more than 255. So when we run a trace route for any destination, it first set the TTL value as 1 and send the packet to the destination. It crosses the first hop, and the TTL value get immediately expired, and we get a message back saying that the time exceeded, right? And that's how we get the source IP address of the first hop. Next time, the TTL value, the packet, the same source will send the packet with TTL value set to 2. This time it crosses the first hop, reaches to the second hop, and the TTL value get expired, and we get a message that time exceeded. This way, we get the source IP address of the second hop. We keep getting it until we reach to the destination. So that's how we get the trace route and the source IP address of every hop. So yeah.
Okay.
Yeah.
So can you tell me what is IPSec VPN and how does it work?
So IPsec VPN is a a network for having a secure connection over the public network or over the untrusted network. So we establish the encrypted session on top of maybe internet, or of course we can have it on any network. It just establish or add an additional layer of confidentiality or encryption, I would say. So it helps to achieve all the factors of cybersecurity, from confidentiality to integrity, authenticity as well. So IPsec basically tunnel has got two mode. Uh, two part, I would say. So there are two phases. So first is ISEC MP phase. Second is the IPsec phase. So in the ISEC MP phase, there are certain parameters need to be matched in order to establish this phase one. So the phase one need to match parameters like pre-shared key, then then encryption algorithm, the hashing algorithm, like AES 256, AES 128. It's like encryption algorithm, hashing algorithm like MD5 or SHA-256. This should match, and also DH group or lifetime parameter. If this matches, then only we could see the security association coming up on the phase one. We are on the Cisco router, we can possibly verify it by using show ISEC MPSA, and we should see the security association coming up. In the phase two, then we do more or less similar activity, calling the encryption, defining the peer gateway. We also specify a rule that what would be the interesting traffic that is going to be encrypted and decrypted on the tunnel. It's usually in some of the firewall, it is denoted as proxy ID, local and remote proxy ID. It's nothing but the LAN prefixes, or encryption domain, or maybe interesting traffic as well. These are different names for it. So we define it. This access list or the security rule should match on both the side. If it does not, the tunnel will not come up. If there Once this is done, we could see the phase two also comes up. We can verify that. If it does not, then we'll have to troubleshoot what's the problem. Maybe by running the some diagnosis command, or verifying it by using verifying if there is any NAT device in between. We probably have to allow port 4500 as well. So this is what IPsec is, and this is how it works here.
So Rajneesh, I'm moving my questions on Checkpoint Firewall now.
Okay.
Do you have experience with Checkpoint Firewall?
Yes, I do have.
What's your experience?
So with Checkpoint, I work pretty much from managing the Checkpoint firewall. I work with different Checkpoint hardware as well, including some of the virtual appliances as well. I work with the 16,000 appliances, 7,000, and some of these smaller versions as well. I worked in setting the checkpoint in the standalone mode, and even in the high availability as well. My experience is majorly in the implementation. I haven't worked a lot in terms of designing, but I majorly work on the implementation of the checkpoint hardware. Work with different blades, including for the VPN, anti-bot, IPS blades. I even work with the mobility blade as well, and I even work pretty much in terms of troubleshooting any issue related to checkpoint, any issues related to the firewall, failover issues as well. And so yeah, that this is have been my experience so far. Yeah.
Okay. Then what are the main components of Checkpoint Firewall?
So the main components is from my point of view just three. I mean, we have security gateway, which is our firewall itself. So that's involved in the network traffic inspection and everything. Then we have management server, or in short, we call it as SMS. Okay, so this is basically used to manage all our firewall policies, objects, and even their entire management as well from the centralized server. So the centralized server is called as management server. Uh, we can monitor every security events into it. We can create a policy and push it to a specific gateway as well. It's all possible through the management server. Now the third component is the console. Now console is basically the client. Okay, it's a client software used by the firewall admin to access the management server. So if I want to access management server, I have to have a smart console in my system. I can just enter the IP address of the smart server, management server, enter my username and password, and I can access the management server. I'll get the beautiful user interface of it. I can see the policies, objects, network configuration, and everything around it. So these are the three important components here.
Okay. So what are the stealth rules in the checkpoint?
So stealth rule are basically rules that is secure, restrict the direct access to the firewall. It is majorly to restrict any unauthorized access to our checkpoint gateway. So we can configure it in such a way that only a specific set of user can access it, and rest of them, if they try to access the gateway, it will be dropped. So that's the stealth rule. Yeah.
Okay. So then
Uh-huh.
what are explicit and implicit rules in checkpoint?
Explicit rules are basically the rules which are explicitly configured. I mean, manually configured by the firewall admin. So it could be anything. It could be related to user security policy, creating any other business, any security rule based on the business requirement or a user requirement as well. So the rules which are manually configured are explicit rules. Rules that are built by the firewall itself, the default rule, I would say, are called as implicit or maybe implied rules. So default rules that are created by the firewall, even when we don't have an explicit rule, and if there's no explicit rule matches the traffic, the default rules automatically be enforced by the firewall itself. We just need to make sure we have a basic connectivity and protection by allowing the common type of traffic into the network. So that's the only need. Otherwise, implicit rules are the default rule. Yeah.
Okay. So then what is SIG in checkpoint?
Second checkpoint is basically, it's basically the communication between our checkpoint gateway and the management server. So as I said, a management server is the centralized dashboard, a centralized server that manage all the firewall. So that connection, that's the connection between the management server and the gateway is called as SIG. I think the full form is secure internal communication. So this is basically an encrypted session, and so yeah, I mean all the communication, all the enforcement happens on this tunnel itself to the gateway. So yeah.
Yeah, perfect. So Rajneesh, now I have questions on Cisco firewalls.
Okay.
What's your experience with Cisco firewalls?
Yeah, I mean I worked pretty much with the Cisco. I mean I started my career with Cisco PICs a long back, so you can imagine how old I am probably.
Yes.
But I then
Most of the
I
people
also
started their
work with
career
Cisco
with
ASA. Yeah.
Cisco.
I also work with Cisco ASA 5505, 5585X, worked with the ASDM, and even the recent after their acquisition of Firepower, secure. I think Firepower. I guess that's the name of the I think SourceFire was the name of the company, or the company they acquired, and after that they named it Firepower. So I even worked with the FTD 2100, and which is Firepower Threat Defense, and even worked in with the FMC as well, which is just like our uh, just like our Checkpoint SMS server to centralize manage all the firewall. Similar to that, we have FMC to manage all the FTD appliances from the centralized dashboard. So I even worked with that. I even worked in configuring the IPSec VPN, security rules, URL filtering, and remote access VPN using Cisco AnyConnect. So yeah, pretty good with it. Yes.
Okay, perfect. So then what are the different security levels in Cisco firewalls?
So basically, in the Cisco, we have a default security level, which is for 0 and 100. So 0 indicates the the lowest security level, and 100 is the highest security level. Okay. So by default, the traffic from the low security level to high security level is blocked, and traffic from the high security level to low security level is allowed. It doesn't mean that only traffic from 100 would work. Even if we have a traffic coming in from 90 to 0, will be treated the same way. So because traffic coming in from 90 security level to maybe 10 security level will be allowed by default, because it is coming from high security level and going to the low security level. So that's the default behavior, and these are the security level. And it's, as I said earlier, it ranges from 0 to 100. Yeah.
Okay. So Rajneesh, have you worked with Cisco FTD then?
Yes. Yeah, I work with.
So how is it different from Cisco ASA?
Well, I mean, FTD is, as I said earlier, after Cisco acquired the SourceFire, yes, SourceFire, they because the earlier ASA was just the stateful firewall, but Cisco wanted to get into the next generation firewall domain altogether, because Palo Alto and everyone was getting into it. So they, after acquiring the SourceFire, they renamed their product and their solution as well as FTD. And because when we talk about next generation firewall, it has got a lot of capability. If we look at these legacy stateful firewall, it can only perform the inspection till layer 4, but it cannot see the actual payload, the application header. With the next generation firewall, it can perform the deep packet inspection. So that means it can even see the actual payload. It means it can actually go on the layer 7 of the OSI model and see what's there in the packet. It can also perform the IPS, IDS inspection, advanced malware protection, URL filtering, as I said. So that's the difference, and that's what that's what makes it different. So if we talk about the FTD models and firepower threat defense, they are coming into the next generation firewall appliances. They have IPS, IDS, malware protection, deep packet inspection, everything around it. So but if you look at the ASA, it's still, it has the packet inspection capability, but it is not on the application layer. So yeah.
Okay, perfect. So how can we configure Cisco ASA in high availability?
Yeah, so ASA can be configured in the high availability because it requires the firewall. I mean, we can have ASA configured in active standby or active mode as well. So it's just that if we are setting them up, we have to set up the failover interface on the primary ASA. We have to assign the failover IP address on the primary firewall using their LAN fail interface, and then we assign the external IP address on the primary firewall. And we also have to create the internal IP address on the primary firewall, and then we can verify if the connectivity is going good or not. On the active side, we divide the traffic flow between two ASA, and benefit benefit of having active from the active standby is very significant, because if we see firewall, they have a problem with the asymmetric routing. So if we have a network, if we have a firewall where the packet goes forward, traffic goes to the firewall, but the return traffic does not come up, the firewall will not treat that as a session, right? It's because it needs the stateful behavior. And same thing happen if the forward traffic does not come to the firewall, but only the return traffic comes in. So it will drop the packet because it's not a part of the stateful session. So when we have active standby, it is good. If we have a smaller network, we are very much sure that our routing will be like this, where the forward and return traffic will always come to the same firewall. But we should use the active firewall design when we are not sure what would be where the forward and return traffic might go. So irrespective of where the traffic would be coming in, it will treat that packet, and it will take it into the station, stateful inspection, and it will not drop the packet. So it is good if we have a large network complex environment, we can keep that into cluster. So yeah.
Okay. So, Roshish, did you work with Cisco IPS?
Yes, absolutely. I work with it.
How to configure Cisco IPS?
So I worked with it because Cisco IPS is actually created by using the SNOT IPS. So SNOT is having two licenses. It's freely available. There's a community license. There's a paid and commercial license as well. So SNOT IPS is completely free. We can use their community license, but if we want to go for IPS, it is for Cisco, it is recommended to have the commercial license. So IPS basically, it looks at the packet signature. Every packet that goes through the network has got a signature in its header. So for example, if we look at the HTTP traffic, right? So HTTP traffic has multiple header, user agent information and everything. User agent is like your browser name. So let's say if I'm trying to access google.com, so my HTTP agent would be Chrome browser in my case. For you, it might be Firefox. But if it is coming as any invalid name or unrecognized browser name, it will treat the IPS or IDS detected as the intrusion or possible suspicious traffic, and it might drop the packet, or it might create an alert and send it to the admin. So that's all can be done using the IPS. And in order to configure it, I mean, we just have to because NOD is already integrated into the system. We just have to import the rules. We have to create the rules, or we can get it from this NOT IPS community, or maybe the commercial license. We can buy the license, we can update it or import it into the system. Currently, we have SNOT version 3. Many of the organizations have already migrated the SNOT version 2 rules to version 3, and because it's really powerful. So yeah, that's the way we configure it. Yeah.
Okay. So now I have questions on Fortigate firewalls.
Okay.
What is your experience with Fortigate firewalls?
Pretty good. I mean, I worked with the Fortigate as well. I mean, I worked in configuring Fortigate firewalls, worked with many small appliances, and even I worked with the some of the larger one as well. I worked with the smaller appliances like 60E, 90E, 200E, 400, the 400 devices. Even I worked with the 500 and some of the larger ones such as 2600, 1800 F series as well. I worked in configuring the security rules, worked in setting up the URL filtering, even worked with the managing SD-WAN on the Fortigate, setting up the IPSec VPN, remote access VPN. I even worked with the 40 switches it's very cool because we have 40 link capability that works with the Fortigate as well and other Fortigate devices as well. I work with creating different security profiles like antivirus rules, web filters, application controls, file filter, even work with the web application firewall, DLP policies as well. So yeah, we'll work pretty much with that. Yes.
So, what is your experience with Fortimanager then?
Worked pretty good with it. I mean, I worked in managing Fortimanager. Fortimanager is just like our, as we discussed earlier with Checkpoint, it was SMS. With the, with Cisco, it was ASDM or FMC. With FortiGate, it is Fortimanager. So with Fortimanager, we can manage all the FortiGate appliances directly. And if we want to add any FortiGate devices to the Fortimanager, we can navigate to the device tab of the Fortimanager. We can create new and add a device IP address, admin credential, and some of the other relevant information. And then we would be able to add the device into the network. It's just that we need to make sure it is connected to the network. The hardware is connected to the network for that. And if we want to sync the device and group, we can go to the device manager. Under the device and group, we can right click and import the policy to launch import policy wizards as well. So that's how it could be done. Yeah.
What is VDOM in Fortigate?
So VDOM is like context. It's a feature in the Fortigate to creating multiple virtual firewall within the single physical appliances itself. It's similar to the context feature of Cisco Firewall. So each VDOM operates independently. They have their own resources. They will have their own configuration setting, security policy, interfaces. They will have their own routing table. The purpose of VDOM was to have the segmentation. So let's say we have the east-west traffic in the network. We can create a VDOM so to take care of one specific domain, to take care of one specific area as well. Let's say I have internal DMZ, external DMZ, and I have server farm area. So for every area, I can have the different VDOM created, and I can then reroute my traffic to come to that DMZ firewall. And because for that, I don't really have to make sure that I buy a new firewall altogether. I can just use my existing firewall. It's just that I create a different VDOM for that, and it will treat all the licenses, all the features will be applicable to all the VDOM accordingly. So yeah, it plays a very good role, a very important and critical role for segmentation as well. So yeah.
Okay. Then what is Fortinet Security Fabric?
Well, I'd say it's a Fortinet proprietary, I would say, security concept, which basically talks about the just like we have a network fabric, right? Data center fabric. It's the Fortinet security fabric, which allows them to include all their appliances, because just like we have in our Apple ecosystem, right? So Fortigate is also have their own security ecosystem where they have their firewall, endpoint security, secure access gateway, SD-WAN, everything. So they connect all the devices together so that they can help the organization to automate detection, protection, and respond quickly as well. So that's where it becomes very helpful for automation, where they integrate everything. I mean, from 40 client to 40 sandbox to 40 APs, 40 switches, everything together, and it helps. It really helps. I mean, I have personally experienced that. It beautifully get integrated with all the appliances directly, and because there is no compatibility issue, it becomes very friendly as well in terms of configuration. So yeah.
Okay. Then Rajnish, what types of security profiles have you configured on FortiGate firewalls?
Well, I mean, I work with multiple security profiles. I work with the antivirus profiles. I work with the IPS, web filter, application control, email filtering. DLP, all those. So work pretty much with this. Yes.
Okay. So Rajneesh, now I'm moving my questions on Palo Alto Firewall.
Okay.
What is your experience with Palo Alto Firewalls?
Well, I work pretty much with the Palo Alto as well. From like last 3-4 years, I've been spending good amount of time with Palo Altos. I worked with the different Palo Alto hardware. I worked with the 800 series, this smaller one, or I would say small to mid-size one. I even worked with the larger appliances, including 3000 series Palo Alto hardware, 5000 series appliances as well, and even worked in creating the different security rule, NAT rule, antivirus rule, anti-spyware rules, vulnerability protection rules. Uh, Even worked in configuring wildfire onto the Palo Alto, setting up the remote access VPN using Global Protect, configuring the IPSec tunnel with remote branch office or maybe with business partner network, and also been being very comfortable in terms of connecting them to the Panorama dashboard, Panorama management server, and then organizing the firewall based on a device group and pushing up the configuration based on their template and template stack as well. So yeah, work pretty much with it. Yes.
Okay. So in Palo Alto, what is the difference between virtual routers and virtual systems?
Okay, virtual router is like VRF, the virtual routing and forwarding. It's like we create a separate routing table to avoid any kind of IP address overlapping issue. So with virtual router will create its own routing instance, routing table, interface, routing protocol. So everything can be created separately. Virtual system is like what we discussed with in the earlier Fortigate related questions where we discuss about VDOM, right? So VDOM and vSys virtual systems are similar in a different platform. So vSys is like creating different virtual firewalls from a single physical firewall. But the purpose is again the same. The purpose is to have the segmentation of the network. We can create multiple virtual appliances and then allocate the resources, segregate the configuration policies, security setting, as good as a altogether different firewall, right? So that's where it becomes very helpful. So yeah.
Okay. So
Mhm.
in Palo Alto, what is a U-turn NAT?
So U-turn NAT is very interesting because it is a feature of Palo Alto where we allow or force the internal user to access the internal application or internal server using the public IP address. Okay, so in this case, when a request from the internal host is destined to a public IP address of the internal server, the firewall actually perform the NAT translation of the packet and then redirect that back to the internal server private IP address. So user will always see the public IP address, and the firewall see that public IP address and add it to the private internal resources. So that's basically to simplify the network configuration to make sure what's internal remain internal and maintain the consistent access policy across the network. So yeah.
Okay. So what is a zone protection profile?
Zone protection profile is basically, it's kind of to protect the firewall itself, right? So zone protection firewall is a set of policies, set of rules, policy to protect the network zones, okay, from any kind of attacks or threats. Majorly, the main focus is the flooding related attack or maybe packet based denial of service attack, maybe ICMP based denial of service attack, application based denial of service attack. Or maybe someone is performing, attacker is trying to perform a scanning or reconnaissance. So it is like control plane protection policy. This kind of a keyword we use to see in the Cisco appliances, but in the case of Palo Alto, we call it as zone protection profile. So this is also help us to protect if someone tried to send any launch any kind of network based attack like send flood attack or half open session attack or UDP flood into the network as well. So that's where it becomes very helpful. So yeah.
Okay.
Yeah.
So what is an app ID in Palo Alto and how does it work?
So app ID is very interesting feature, and that's what I think the USP of Palo Alto as well. I think definitely in the beginning. So app ID is like the application ID where firewall basically identify and classify the network traffic based on the specific application and services used in the network. And uh, earlier, what used to happen is if let's say someone want to access Google or maybe Google Docs or Google Sheet or anything related to that, we allow the access to Google, and then we leave it to the user whatever he want to access. But now, in spite of relying on just website name and ports and services, we also see if it is a really that genuine application that user is trying to access to. So for every application like Google Docs, okay, so Palo Alto has built this set of list of thousands of application that our organization is trying to access to. And then in spite of you allowing the access to entire google.com, you can just simply ask the user, I know you want to access Google, but what's inside Google? Do you want to use Google Docs, Google Sheet, or maybe Google Chat or Google Meets, what it is? So accordingly, you can be very, very specific about the packet, that about the rules that you want to allow. So it's like least privilege access method that is developed by Palo Alto. So app ID is basically the simplified database of application signature and behavior. It also builds the behavioral analysis as well about every application. So when we go to the app ID of Palo Alto, we also see the high risk to low risk application in the organization. We can classify the organization, classify the rules accordingly. And let's say we want to create the whitelisted rule or blacklisted rule, we can see the risk of every app into it, and then we can take the proper action as well. If we want to create a rule, we can create security profile for it, and then once we create the security rule, we have an app and service section that's where we can call the specific app ID, and it will be allowed. Usually we call it in the security profiles. That makes our job easier as well, but we can also call it into the security rules and it would be done. So yeah, that's app ID. Yeah.
Okay, perfect. So Rajesh, this is all I have on the security related questions. Thank you so much for your time.
Thank you so much, Jamin. And this is all we have today. Thank you so much, everyone, for watching all the questions. If you have any question, do let us know in the comment section. We would love to answer that. Thank you so much.